Okay, guys, good morning or good day, Max Size students, grade 8 students. For this lesson, for Module 6, we have Rhombus and Square. So we're going deep into the properties of rhombuses and squares, and also we're going to prove the properties of rhombus and squares. Okay, so what you see here is a chessboard. Okay, so chess is quite popular these days because of the show The Queen's Gambit, and also other types of squares can be seen in different parts of our lives. So we often see them on our smartphones. So we have square shaped tiles on our smartphones. Okay, and for chess we have 64. Okay, so in the chess there are 64 square tiles. Okay, and also rhombuses. Rhombuses can also be seen can are also seen on buildings. Okay, when you see the windows that are shaped or trellised into different figures or facades. Okay, so there you go. So those are some of the common examples of rhombuses and squares on windows, on smartphone app tiles, okay, and also on chess, and many other things. Okay, so let's start with the isosceles triangle theorem. So this is quite a primer or a bit of a prerequisite in order to understand the properties and to prove the properties of a square. So we have here the isosceles triangle theorem. Okay, so let's say for example we have here an isosceles triangle. Okay, so let's say we have here triangle ABC. Okay, so it states here that if two sides of a triangle are congruent, so let's say for example, side AB is congruent to side BC, therefore the angles opposite to those sides, so angle C and angle B are congruent to each other. Angle C and angle A. Angle C is congruent to angle A. So the opposite angles, okay, so the angles that are opposite of those sides are congruent. So the opposite of AB is C and the opposite of BC is A, and therefore angle C and angle A are congruent. And it's converse, okay, so the opposite of that is the converse of the isosceles triangle theorem. So if two angles are congruent, so let's say for example angle A and angle C are congruent, then therefore the opposite sides of the triangle are also congruent. Okay, so let's try to prove that. So using a paragraph proof, we want to prove that angle RFM, okay, so this angle is congruent to angle ROM. Okay, so using the isosceles triangle theorem. So using a paragraph proof, consider the perpendicular bisector RM. Given that we have here this perpendicular bisector in this isosceles triangle, it can be said that RM is congruent to RM using the reflexive property of congruence. And also by a definition of a perpendicular bisector, we can say that FRM is congruent to ORM. So these two angles are congruent because line segment RM is a perpendicular bisector, because a perpendicular bisector also acts as an angle bisector. Okay, and also we have a perpendicular bisector also creates a 90-degree angles from the point of intersection. So you have your 90 degrees here, and also we can say that these two angles, angles RMF and angle RMO, are congruent to each other because all right angles are congruent. Then using the ASA, triangle congruence postulate, okay, so using the angle, okay, this one, we know that it's congruent. The side, okay, since we've proven that RM is congruent to RM through the reflexive property of congruence, and also since we know that angle RMF is congruent to angle RMO, then therefore we can say using the ASA triangle congruence postulate, the two right triangles are congruent. Okay, so that means triangle RMF, okay, or FRM is congruent to triangle RMO or triangle ORM. And from there, using CPCTC, we can say that the corresponding sides or corresponding parts of the congruent triangles are congruent. Therefore, since angles F and angle O are corresponding angles, okay, so we can write that. So since angle F and O are the corresponding angles of the two right triangles that we have here, therefore we can say that they are congruent. So therefore angle RFM and angle ROM are congruent, and therefore we have a isosceles triangle that we have here. So we can use, guys, the isosceles triangle theorem in proving the what do you call this? Proving that a triangle, that an equiangular triangle is also an equilateral triangle. So how can we do that? First, we must state our given. So number one, triangle CAT is an equiangular triangle. So that's a given. Okay, so what do you think, guys, can be our second statement for this proof? Okay, so guys, the purpose, okay, so the goal of this proof is to prove that the equiangular triangle ACT or CAT is also an equilateral triangle. So we have to prove that CA, AT, and CT have congruent side measurements. Okay, so using one of the isosceles triangles theorem, the converse one. So the converse states that if two angles are congruent, okay, so if we have the converse of the isosceles triangle theorem states that if two angles are congruent, then their opposite sides are also congruent. So we can state here at number 2, okay, we can state here at number 2 that CA is congruent to AT. Okay. Okay, so we can state that maybe for number 3. But first, we have to write first, okay. Okay, we have to write first that angle C and D are congruent. Okay, so they're congruent because since it's given that we have here an equiangular triangle, we can write here as our reason, all angles of an equiangular triangle are congruent. So that must mean that angle C and angle T are congruent. And therefore, their opposite sides, which are CA, okay, CA and AT, so the opposite of angle C is AT and the opposite of angle T is AC. So we can say that CA and AT are congruent to each other through the converse, converse of the isosceles triangle theorem. Okay, and also we can do the same thing for number 4. Okay, so we can write here on number 4. Okay, we can also write that, okay, for number 4, we can write that angles A, angles A and T are congruent. Okay, so let's write that. Okay, angles A, angles A and T are congruent. Okay, also using the same reason, okay, all angles of an equiangular triangle are congruent. Okay, so let's write that. And therefore, for number 5, using the substitution property of equality, okay, substitution property of equality, since we've said that angle C is congruent to angle T and angle A is congruent to angle T. Therefore, using, transitive property of equality, okay, for number 5, angles, okay, so let's see here, angles C and A, okay, angles C and A are congruent to each other, okay, using the transitive property of equality. Okay, so if angles C and A are congruent to each other, okay, so we can write that here, number 5. Okay, we can write it here, okay, number 5. Okay, number 5 we have here, okay, transitive property property of congruence. So therefore their their opposite sides must also be congruent. So that means for AT, okay, so we have here AT and CT. Okay, so that means AT and CT are also congruent. Okay. So that must mean that AT is congruent. Okay, AT is congruent to CT. Okay, so the reason for that is simply the converse. Okay, converse of the isosceles triangle theorem. Okay, and for lastly, okay, we can now say here at number 7. Okay, now we can now say here at number 7 that, okay, since CA is congruent to AT, AT, and AT is congruent to CT. Therefore, CA is also congruent to CT using the transitive property of equality. And so, okay, we can write that. We can write that here. Okay, so number 7, CA and uh, CA and CT are congruent using the transitive property of congruence. Transitive property of congruence. And lastly, we can now say, since all of the sides are congruent to each other, we can say here for number 8 that triangle CAT is an equilateral triangle, because that's the definition of an equilateral triangle, and we've already proven that all of the sides of this triangle are congruent. So, definition of an equilateral triangle. Because if we look at statement 7, statement 3, and statement 6, so we can say that all of the sides of this triangle, this equiangular triangle, are also congruent, and therefore it is an equilateral triangle. Okay guys, so let's do a review of the properties of a rhombus. So the first one is that all sides of a rhombus are congruent. So it's kind of like a square, okay? So that's why rhombus and square, they have almost the same properties, with the square having more properties as compared to the rhombus. So all of the sides of a rhombus are congruent, okay? So we can check that. And also its opposite sides are parallel, and they're also congruent, and the diagonals bisect each other at right angles. Okay, so there's a right angle here at the center. Let's say there's a point E there. Therefore, UEA is a right angle. Okay, and the diagonals, okay, the diagonals bisect the opposite. Okay, so the diagonals bisect the opposite angles. Okay, so that means we have here. So we have here angle QUD. Okay, is congruent to angle QUD is congruent to angle DUA. Okay, and also the adjacent angles are supplementary. So that means angle U plus angle A. The measurement of angle U and the measurement of angle A is equal to 180, and A, that goes the same for A and D, for D and Q, and also for Q and A. And also we have here two diagonals of a rhombus are perpendicular. Since we've said, or since it was stated here, that they meet at right angles, the diagonals meet at right angles, therefore their diagonals must also be perpendicular. And lastly, we have here two pairs of adjacent sides that are congruent. Okay, so that must mean that it also follows the property number 1, all sides of a rhombus are congruent. So it follows number 8, that their adjacent sides must also be congruent. Okay, so we have here the properties of a square. So we have here 11 properties of a square. The first one is all sides are parallel and congruent, much like the same. So it's the same with the rhombus. All of its sides are also parallel and congruent, and the diagonals are perpendicular and equal to each other. So for a rhombus, the diagonals are only perpendicular, but for a square, they are perpendicular and are equal. Okay, so remember that, guys. For a rhombus, the diagonals are not equal, but for a square, they're equal. Okay, and also we have here the diagonals bisect each other at right angles. Okay, so that means the measurement of angle AUD, sure enough, is 45 degrees, and I'm sorry, DUQ is also 45 degrees. And if we add those measurements, we get a right angle, which is 90 degrees. And that's the angle measurement for all of the angles, or all of the corners, for a given square. And also, the adjacent angles are supplementary, much like the rhombus. The pairs of adjacent sides are congruent, also like the rhombus. We've also mentioned that the right angles are congruent, and also right angles. All of the angles of a square are right angles, and therefore they are congruent. So it is also a quadrilateral. There is also a rectangle and a rhombus. So it combines the properties of a rectangle and a rhombus. So that's the square for you. And then we have a rhombus with four right angles. So a square is a rhombus with 4 right angles. A square is also a rhombus with perpendicular and adjacent sides, and it's also a rectangle with 4 congruent sides. So those are the properties of a square. Okay, so there you go.